When we think about dimensions, our minds naturally gravitate to the three spatial dimensions we live in: length, width, and height. These are as intuitive to us as breathing, an inseparable part of how we navigate the world. Add time as the fourth dimension, and you've entered Einstein's realm of space-time. But is this all there is? Could there be hidden dimensions beyond our perception, as elusive and mysterious as dark matter itself? This question has captivated physicists, mathematicians, and even philosophers for centuries. The idea of higher dimensions isn't just the stuff of science fiction. It's a cornerstone of some of the most ambitious scientific theories today, from string theory to efforts to unify gravity and quantum mechanics. Understanding these higher dimensions may reshape our very concept of reality. The dimensional basics. To appreciate higher dimensions, let's begin with the familiar. In the early 19th century, mathematicians formalized the idea of dimensions. The first dimension is simply a line, length without width or height. Add width, and you have a two-dimensional plane, like a sheet of paper. The third dimension gives depth, creating the 3D world we experience daily. Time is often described as the fourth dimension, not spatial but temporal, creating the fabric of space-time where events occur. However, this concept is still rooted in the observable universe. The notion of dimensions beyond these four is something entirely different, and much harder to visualize. Beyond the observable. Theories of higher dimensions. The legacy of Kaluza and Klein. The first modern idea of higher dimensions emerged in the 1920s, when Theodore Kaluza and Oscar Klein proposed that a fifth dimension could unify two of the fundamental forces of nature, gravity and electromagnetism. Their theory suggested that this extra dimension was curled up into a tiny circle, so small that it was invisible to us. Klein's vision sparked a revolution. If an extra dimension could hide in plain sight, might there be more of them? This question laid the groundwork for later theories like string theory. String theory, the multidimensional universe. String theory, one of the leading candidates for a theory of everything, takes higher dimensions to the extreme. According to string theory, the fundamental building blocks of reality aren't particles, but tiny vibrating strings. These strings can only vibrate in a universe with 10 spatial dimensions and 1 time dimension, 11 dimensions in total. Why so many? The mathematics of string theory requires these dimensions for consistency. Imagine these extra dimensions as tightly folded shapes, known as Calabi-Yau manifolds, that exist at every point in our three-dimensional space. While we can't see them, they influence the properties of the particles and forces we observe. The warped world of M-theory. If string theory isn't ambitious enough, M-theory goes further, suggesting an 11th dimension. Here, our universe might be one brain, a multidimensional membrane, floating in a higher dimensional space. Collisions between these brains could even explain phenomena like the Big Bang. Why can't we see them? One of the most puzzling questions is why we can't perceive these dimensions. The answer lies in scale. Extra dimensions are thought to be minuscule, curled up on scales smaller than atoms. Imagine a garden hose. From far away, it looks like a one-dimensional line, but up close, you see it has a circular cross-section. Similarly, higher dimensions might be rolled up in ways we can't directly observe. Scientists are searching for indirect evidence. For example, experiments at the Large Hadron Collider, LHC, look for tiny black holes or deviations in particle behavior that might signal the influence of higher dimensions. So far, the search has come up empty, but it's far from over. The implications for reality. Why do higher dimensions matter? If they exist, they could radically alter our understanding of the universe and ourselves. 1. Unifying physics. The biggest challenge in physics today is unifying general relativity, which describes gravity and large-scale structures, with quantum mechanics, which governs the microscopic world. Higher dimensions might provide the missing link, offering a framework where these seemingly incompatible theories coexist. 2. Parallel universes. Some theories suggest that higher dimensions might host parallel universes, entire realities that exist alongside our own, separated by just a fraction of a millimeter in a higher dimensional space. Could these universes influence ours? Could they be the source of dark matter or dark energy? 3. A new perspective on existence. If higher dimensions exist, our reality is just a slice of a much larger whole. This idea challenges our anthropocentric view of the universe, forcing us to rethink what it means to exist. Are we just three-dimensional beings living in a multidimensional cosmos? Challenges and controversies. The concept of higher dimensions is not without critics. Some argue that these ideas are untestable, making them more philosophy than science. Without experimental evidence, higher dimensions remain speculative, a beautiful but unproven mathematical framework. Others question whether we're even asking the right questions. Are higher dimensions real, or are they just a convenient way to describe the universe's complexities? Looking ahead. The search for higher dimensions is far from over. Advances in technology, from particle accelerators to gravitational wave detectors, may one day provide definitive answers. If we ever do confirm their existence, the implications would be profound, not just for science, but for philosophy, art, and our sense of place in the universe. Imagine a future where humanity not only understands higher dimensions, but learns to navigate them. Could we build technology to traverse these dimensions, enabling faster-than-light travel or connections to parallel universes? These ideas may seem like science fiction, but so did the notion of curved space-time before Einstein. Conclusion. Higher dimensions represent one of the most tantalizing frontiers in science, a bridge between the known and the unknown. Whether they exist or not, the pursuit of this question pushes the boundaries of human understanding, reminding us that the universe is far more mysterious and wondrous than we ever imagined. So, do higher dimensions exist? For now, the answer lies hidden, curled up in the folds of space-time, waiting for humanity to uncover it.